Okay, so this is the last part of the exploratory data analysis or the basic exploratory data analysis. We arrive at the part 3 of the video. So for the part 3 we have to outline only 3 outlines making sense of the data. First is making sense of data, and then measurement scales, and then we will explore about the ADA compared with the traditional Bayesian. Okay. So at first, we have to understand what is the type of the data, or in this outline is making sense of data. First, the type of the data. There are two types of the data. By the type of it is numerical. First is a numerical data. This data has a sense of measurement involved in it. For example, a person's age, height, weight, blood pressure, heart rate, temperature, number of teeth, and etc. In the numerical data, we have we can also classify into two kind of type. First is discrete data. This is a data that is countable and its values can be listed out. For example, if we flip a coin, the number of heads in 200 coin flips can take a values from 1 to 200. So this is a countable type of data. For example, the number of the person in the class, the number of the student in the school, and then there are a continuous data, a variable that can have an infinite number of numerical values within a specific range is classified as a continuous data. For example, height of the person, weight of the person, that's the kind of value is a continuous data, because there are no limit for the weight of the person, and there are no limit for a height of the person. So it don't contains any specific range. So, and then the type of the data also mostly is a float number, despite the discrete data is a integer number. So the difference between discrete data and continuous data is continuous data tend to have a float format or float number or decimal number, while the discrete data is an integer number. And then we have a categorical data. This type of data represents the characteristics of an object. For example, gender, marital status, type of address, or categories of the movie. So if we have a gender, male or a female, this is a categorical data. And marital status, whether they are annulled, divorced, interlocutory, and etc. And then a movie genre such as action, adventure, comedy, crime, drama. This is a categorical data. Also, further, we have a measurement scales that match that represent for the categorical data and numerical data. First is a nominal. These are predicted for labeling variables without any quantitative value. The scales are generally referred to as labels. In case of a nominal datasets, you can certainly know the following. First is frequency, error proportion, and then percentage. And to visualize the nominal dataset, you can use either a pie chart or a bar chart. Okay, so for example, this data is the gender. The gender is a nominal also, and then the type of the children. Let's say children with good hair and bad hair. Yeah, I think that's the example of the nominal. And then the type of the car, maybe sedan, minibus, or supercar. Yeah, that's a nominal data sets. And then for the after the nominal dataset, we have the ordinal dataset. The main difference in the ordinal and nominal scale is the order. The ordinal have the order in it. For example, is education. We have the elementary school, and then junior high school level, and then senior high school level, and then college level, and magister level, and until PhD level. So in the ordinal scales, we have the order, or we have a level in the data. That's a difference between nominal and ordinal. So, and then the interval scales both the order and exact differences between the values are significant. Interval scales are widely used in statistics, for example, in the measure of central tendencies such as mean, median, mode, and standard deviation. Interval is also the simple example of the interval. If you ever to fill survey, you know, survey online sometimes uh, provide some scala Likert. So Likert scale is a interval also. If you happy with us and then type a 1 and then higher is better or small is better, and then the ratio scales contain order, exact value, and absolute zero, which makes it possible to be used in the descriptive and inferential statistic. For the example is weight, height, and etc. Yeah, so after understanding the type of the data, and then we will compare the data with a classical and Bayesian analysis. The classical data analysis, for the classical data analysis approach, the problem definition and the data collection step are followed by model development, which is followed by analysis and result communication. While exploratory data analysis approach, the main focus is on the data, its structure, outliers, models, and visualizations. Generally, in ADA, we don't impose any deterministic or probabilistic model on the data. And then the Bayesian data analysis approach, the Bayesian approach incorporates prior probability distribution knowledge into the data analysis steps. So yeah, the ADA part here is a difference significantly between classical and Bayesian. The ADA only focus in visualizing the data, conduct the insight from the data. Meanwhile, the other is calculate the probability and calculate the model, and then for the classical, which is followed the analysis and result communication. Yeah, so the ADA is the essential of the ADA is the part when we visualize the data, we create a graph, we create a diagram, we write some conclusion, we write some paragraph that interest our stakeholder or our boss. So this is the step of this is a difference between the classical data analysis. In here we have a problem definition, data collection, model development, and data analysis, and then result communication. Meanwhile, the exploratory data analysis, the different place of the data analysis is in here. So in exploratory data analysis, the data analysis step is in the third position, while in the classical is in the fourth position. Meanwhile, the Bayesian data analysis, the data analysis step is the second last position. Yeah, I think this is the differences between the classical exploratory data analysis and Bayesian data analysis. So this is the end of the section. This is the end of the basic exploratory data analysis. I hope you understand. And I hope you will apply it soon, and see you on the next video.